Hi, welcome to Teardown Tuesday. Today we've got a brand we haven't torn down before. This is a Siglent SDG5082 or 5000 series function slash arbitrary waveform generator. It's quite a decent bit of kit. Goes for over 4 digits, so let's not muck around. Let's take a look inside. No, I haven't even peeled the tape off the front. Haven't even powered it up after taking it out of the box. You know what we say here on the EEVBlog, don't turn it on, take it apart. Actually, I will stand corrected on that 4-digit comment, or over $1,000. Yes, it is over $1,000 for the 160 megahertz version, but this is the 80 megahertz version. I believe the only difference is the maximum output frequency. The sample rate, 500 meg samples per second, is the same between units. And so this one, the 5082, you can get this for under $600 street price. I think it goes for just slightly over 800 from the official rep here in Australia. That's in Australian dollars with the bit of a weak Aussie dollar at the moment, but yeah, quite an affordable function gen actually, and of course it competes directly with the Rigol DG4000 series, which we've seen in quite a few videos now. But this one, they claim they won up the Rigol with this easy pulse technology in this thing, apparently, so which allows for lower phase noise, lower slash jitter, and greater resolution in terms of being able to set the duty cycle, the pulse width, stuff like that. So you can get really fast edges apparently at low output frequencies. So anyway, yeah, it does have USB. This isn't going to be a review, of course, but we haven't seen this before, so we probably shouldn't. Probably should just give a minute here to give a brief overview. I have not powered it up, as I said, haven't used it, so I don't know how it operates. Clearly these buttons all light up, all the soft buttons. Very small little keypad here, so it doesn't take up a huge amount of room. Nice indenting on the big knob there, I rather like that. And yes, it's pushable. It's got a secondary select function, really nice. Channel 1, channel 2, I believe the second output has much greater memory. I think don't quote me, 16K on channel 1 and like 512 on channel 2 or something. For some reason, lots of soft buttons along the bottom, big graphical color LCD display on the thing, and a couple of mode buttons. And well, that's a bit obviously got a fan on the side, so it does heat up a bit. And on the back we've got a USB device, external trigger, gate, FSK burst, multifunction. We've got modulation in, we've got sync out, we've got 10 megahertz external, 10 megahertz reference in. Excellent, so you can hook it up to your Rubidium standard or something like that. Fantastic. And the reference output if you need to synchronize the internal reference with something else. But apart from that, it's pretty Spartan. Universal AC input voltage. There is one thing though that irks me a bit, just these little tacky gold QC pass, QA pass by, tester number 01 and QA operator 01. It's just, they're the sort of type of exactly the look and feel of the stickers you get on just the real cheap crappy stuff that comes out of China. I know it's only minor, but it just gives me that impression. But anyway, the unit does feel very good, so we've got no problems whatsoever. The tilting bail actually, it's not too shabby. So anyway, let's see if we can crack this open. It's got these rubber surrounds. There we go. They just pop off, so looks like they don't hide any screws or anything. They could actually come off. I probably prefer like the full rubber boot like you get on the Agilent gear and stuff like that, but it looks like we have 2 screws here, and it looks like that back will pop off, and then the whole chassis there will just slide off. Warranty void if broken. We can deal with that, no problem whatsoever. Yeah, there are methods to actually get those off, but big whoop. So let's crack this open. We've got a standard Phillips here. Now we haven't, by all accounts, they're not too bad at all, so expect a reasonable standard of quality in terms of the design and the build quality of the manufacturing quality of the PCB. They must have captive screws in there, I think. No, it doesn't. It just popped out, and I better pick that up before I lose it. And it looks like, is that going to slide out, or have we got another one holding it in? No, maybe we have to take the handle off. No, turns out that we didn't. There we go. Got some nice, they've removed the paint there, just so that they can get some extra shielding on the case. That's rather nice. And I can see some nice RFI gaskets here. I've got it upside down. Oops, all the electrons will fall out. Got to be careful. Whoa, that looks really nice inside. But there we go. Got some very nice gaskets there. Nice attention to detail for the EMI shielding on that thing. And this, folks, looks really, really good. Now, at first glance, I was going to say I don't mind the build, the design and layout and build quality of this thing. And, well, yeah, I don't mind the, modular board construction and stuff like that. It looks fairly neat. They've got metal shielding in the middle here. They've got clearly the mains power supply on this side here going across, all separated. Nice big mechanical clunking switch, which I don't know if that's the real, yeah, it looks like the real deal because we've got mains wiring running over here and going like that. Anyway, I was going to say I don't mind that, and I don't, but the first thing I noted was the cheapness of the metal in this, and then I looked closer, and even from a distance, I'll get my macro lens out, but it looks like the chassis is rusted along here and here. Oh. And there you go. Look at that. That is just truly awful. It really is. To get a factory fresh unit straight out of the box and then have, rust on top of the damn thing. I have to get a screwdriver and try and give that a scrape, but that is just truly horrible. And it's not just in one spot either. Let's go to the other side. And there's the other side. I mean, look at that. It is just horrible. It really is. Oh, man, that's just... thumbs down. And then the rear panel, they've just clearly just welded that on instead of, screwing that in place. So it just looks and feels really cheap quality. I don't like it at all. Now, I know diddly squat about welding, so I clearly can't comment on that. So maybe someone with, any welding experience might be able to comment on that. But it's just so cheap and nasty. And combine that with the rusted chassis, you gotta be kidding me. And they've done the same on the front panel here. You can see the rust on the left-hand side of the connector there on the side. And then they've just spot welded those tabs there. I mean, it's all actually folded up from the bottom of the chassis, but it's all one sheet from the bottom and folded, but then at the top of the chassis up there, they've just spot welded together. And then if you have a look in there at the cable penetrator that goes through the front chassis for that ribbon cable there, it's just punched out and folded, and there's some rust on that too. Looks horrible. So you can see what they've done. This is all one sheet, and they've obviously cut out all of this bottom for the PCB here. Not entirely sure why you would need the bottom on there exposed, actually. But anyway, they've decided to do that, and it's folded over here. They've obviously just put the decal sticker on the back there. So they've folded that down, folded it over there, and then they've spot welded the sides and also at the front here as well. And I can't really get the camera angle in there. It's very difficult, but right up under there you can see huge big scrape or file marks or something, plus more rust. Well, let's forget about the shocking rusted chassis for a minute and have a look at the electronics as in-depth as possible, because it actually does. At first glance, it looks really good. The soldering and the construction and the design quality, as I said, they've clearly got like all the major processing and display stuff and logic stuff. Majority of it's happening on this board over here, which is opto isolated. There we go. We've got some analog devices isolators will take a serial isolators will take a look at there. So they're jumping that. That's why they've split the boards in there. You can see that the output B and C's, of course, they're actually to the input or the output side here, so they're actually referenced to there. So the ground reference on the these inputs and outputs on the rear terminal, of course, will be ground referenced to the main function gen outputs there. But the USB, of course, is isolated because that's all part of the main processing circuitry in here, and then isolated by our analog devices isolators there. Of course, it's got its own separate power coming across here from the main board, and then the main output board here, of course, looks like multiple supplies, of course, coming from our power supply over here, and our power supply over there, which we'll take a look at, looks really good. But it's really difficult to get down in here and take macro shots of the chips and everything without taking the boards out. So I'm going to have to do that. I'm going to have to basically strip this thing completely down, basically the screws down in here. So I'll have to do that. We've got some nice little right angle board mount coaxes coming off here, really good, to the output terminals. So that looks really quite nice and well laid out. So I'm quite impressed. Now, I don't mind what they've done with the earth in here at all. You know, they've taken it through here, they've got it up to here. It's nicely crimped, and with a slide crimp connector going onto there. It's all rather nice, and I like the layout, of course, of the board in there, which we'll go into. But of course, this is a PCB mount IEC connector. So the first thing I think of as well, there's through-hole pins going to the bottom side. How much clearance to the case? Now, if we have a look on the bottom side here, you can see there is bugger all clearance there. And at first I thought, oh my goodness, that is just, awful. It's going to short out and everything. But but because this is a separate physical board in here, it does look like they do have larger standoffs in there. So that's sort of the top of the board lines up with there, so it's going to be 1.6 millimeters below that, and then you're going to have the pins extending out. Then you've got the thickness of the sheet metal, which is really thin and crap and rusted, of course. So I don't know, it may have enough clearance in there, but I hope they've put like an insulating sheet or something over that. Actually, just going back to the rusted chassis here for a second, you can see like down the side wall, it's almost as if like they've I don't know all my sheet metal mechanical processes and stuff like that, but to me it almost appears as though they've tried to deburr this thing or something. You can see all the scratch marks along the side of it, and that is just caused it to all rust. And as I said, I can see a similar thing up under the front panel, but even worse than this. Well, I've got the board out, and this really is quite a nice piece of work. I'm relatively impressed by this. As I said, the big clunking main switch over here, they've even got nice cutouts in there, high voltage isolation slot routed out of the board in there. Very nice indeed. So we'll whip that off, and that just only gets in the way. And of course, here's the secondary side, and we've got some really nice Celastic. Somebody's gone to town with the hot snot gun there, and they've Celastic all that down. We've got some inductors in there, our output caps. We'll take a look at the brands. There's our output diodes there, and it's designed very well. We've got our isolation slot under our optocoupler there. There's our reference circuitry down in there, and really nothing else on the secondary side there at all. There's our suppression from the primary side to the secondary side, and now I was going to say all the isolation was quite nice in here, but you'll notice why they've sort of, look at that, there's not much clearance in there. It's probably going to be good enough, but look, they've gone to town to, remove all the copper fill out of here and do the nice isolation slots in there, yet they ruined that by bringing this trace. I mean, they could have, snuck it sort of down this side and around to the suppression cap there, but they haven't. They've just, look, that's pretty darn close, and they've filled that in. They've put a big square in there. Don't know why they've done that. They've blown it, but it's, it's good enough. But yeah, they just missed that little attention to detail. Then we have nice little touch. We've got our isolation slots between the individual pins of the driving transistors on the primary side of the transformer here. So that's a nice touch. They knew what they were doing there, certainly. And also, they've done isolation slots in here for the main diode bridge as well. And on the primary side here, they haven't skimped at all. Of course, slow blow fuse protection. Once again, Celastic down. They've got a full cover over that. They just haven't left its arse flapping in the breeze there. We've got a thermistor. We've got MOV protection down there. We've got the filter in common mode choke. It's all happening. Very nice. No problems whatsoever. The main cap is a Rubicon 105 degrees C rated 400 volt 220 mAh MXC series. You know, it's not a one hung low cheapie. They've chosen a reasonable brand there for the price. And for those playing along at home, the main controller is an NXP TEA1610T. And that's actually a 0 volt switching resonant converter controller, and that's exactly what they're implemented here. And it's hard to see, but these are, the output caps are 105 degrees C rated Rubicons as well, so they haven't skimped. And if we get our depth gauge on the post in there, we're looking at just over 5 millimeters clearance. And if we have a look at the depth of that pin on the board, almost, it's about 2 millimeters. So that 3 millimeters clearance is going to be adequate there to the chassis for normal use. I can't remember the regs, the exact values from the regulations off the top of my head, but yeah, it's probably going to be good enough. I really would have liked to have seen some an insulation sheet under this board between all of this mains input circuitry and the chassis though. And they've gone to the trouble to actually hold this ribbon cable down onto the flat flex connector down there with some tape. Look at that, they've actually taped it all the way down there, which goes onto the connector. So to get that out, I can't just lift the tabs as usual. I've got to actually peel off all that tape. How annoying. And we've got the main processor board out. It does look quite good, as I said. And let's take a look at some individual devices and the soldering quality. And no surprises on the main processor front here. Analog devices, Blackfin DSP, which we see time and time again in all of these embedded scopes, the Rigol ones and all sorts of brands we know and love. They've got Blackfin DSP devices in them. Analog devices must be laughing all the way to the bank. And right down the bottom, a populated JTAG header connector, just raring to go. Hack away. And at first check, I can't really ID that Texas Instruments part there. Clearly it's the main clock driver PLL, so 25 megahertz main crystal, generating the higher frequencies required for the system operation. And the only other major device on here is this Lattice Semiconductor Mark XO PLD. It's not even a CPLD, it's just a sort of a low-end PLD, although these PLDs are actually quite fast. This one will do 388 megahertz. It's only got 640 lookup tables, it's got 320 macro cells, it's got 6K of high-speed SRAM in there, but that's about it. And here's a classic example of where you would use a CPLD or PLD over an FPGA. For example, you just need some sort of glue interface logic between the main Blackfin processor here. We've got our main memory in here. You can see the traces going down here, so obviously it's doing some sort of memory controlling there. It's obviously got data linked into the processor down here, but then it goes off to this main connector, which is all the serial lines which go over that optical interface we saw back at the start that controls all of the outputs. So that is all the serial interface for that sort of stuff, and it also controls, look, all these traces all tied into the front panel stuff. So it handles all that. So it really is a big part of the system glue logic here. And then coupled into all that, we've got our Hynix DRAM here, fairly high density one, I think it's 4 meg by 16 bits, and our expansion flash memory, which of course contains all of our processor code. And it looks like we've just got a couple of low-end switching regulators down there from the main DC input here. And then we've got an ISP1763A USB on the go. That's pretty much it there for the main processor board. I forgot a programming header up here for the Lattice PLD as well. But apart from that, well, that's all she wrote. So that's quite well designed and laid out. No issues there whatsoever. Let's go have a look at the main output board. And the main board here, as I said, looks to be very well designed and laid out. They seem to know what they're doing here. We've got our regulation circuitry up the top here. These are all obviously low dropout regulators for all the various rails, which is why they can get away with no regulation on the output of the converter up there, because the main power supply board, because then they're just locally regulating them down here. And of course they're going to use multiple taps there because they want the lowest possible power dissipation in these devices. They're only using the PCB as the heatsink in there, so that's why they've just got the multiple voltage rails there, of course, because you've got rails for your analog stuff. It might be, say, you know, plus minus 12 volts or something like that, plus you need your 3.3 and other 5 volt and other rails as well. And heatsink on the main device here, I can't seem to get that off, so sorry, I am not going to try. I do want this thing to actually work when I put it back together, so unfortunately it is probably stuck on with some of that heatsink glue, so that's not coming off real easy. We've got a TX DAC here, which we'll take a look at. A chip with its number rubbed off. You've got to be kidding me. As we said, the serial opto-isolated interface coming in here. They've got ground plane around. It looks like we've got some more switching power supply stuff up here. Relays everywhere in quality NEC brands, so they haven't actually skimped on those at all. Some miscellaneous analog stuff happening around here, and it looks like two identical channels for both channel 1 and channel 2 here. And then it looks like we have a cap and a transient suppressor going down to mains earth on both channel 1 and channel 2 outputs. Now, of course, I could hazard a pretty good guess of what's under this heatsink. It's going to be a Xilinx or an Altera or maybe some other brand FPGA. You know, it's almost for sure that they're going to have an FPGA in there implementing their True Pulse technology, or Easy Pulse technology, sorry, and that's coupled into our SRAM on either side here. We've got a TX DAC, which we'll take a look at. Mystery device here that's been sort of rubbed off. I don't think it's been laser etched. It's not quite straight and perfect enough for that, so they've probably got that on the grinder there and just grinded away. Why? Geez, it's not going to stop anyone. If you really wanted to find out what that chip is, a day's work tops. Unbelievable. Give me a break. Now, this thing actually boasts some pretty good phase noise jitter specs, and here's why. It BT05078, it looks like a Chinese manufacturer I've never heard of, but it seems to be a TCXO, temperature-controlled crystal oscillator. You can see the multiple footprints they've actually put in there so that they can choose a suitable device for production later. Maybe a higher spec version or something like that. And right next to our external input connectors here, we've got an Analog Devices ADCMP562. That's a dual PECL ECL comparator. Extremely quick. We're talking 500 picoseconds output rise and fall times. Very nice. And there's that dremeled off chip. You've got to be kidding me. It's tied into the presumably FPGA down here. I couldn't readily identify those devices there at first glance, so they're presumably just op amps. They've got two there, presumably driving some outputs or some inputs there, and then they've got another one over here as well. And as we've mentioned a couple of times, here's these Analog Devices ADAM Series 1410 digital isolators, and they've decided to use these instead of your regular opto couplers that you traditionally find in these applications. These are just nicer, higher spec, higher performance. You don't have to worry about various issues and stuff like that. They just work, digital in, digital out, magic kind of devices. They do cost more though, unfortunately. And it looks like we have some sort of current shunt thing happening here with some sort of maybe instrumentation amp tacked on there. And there's the SRAM we've mentioned before. It's a Cirrus Logic part, and it's a 512K by 18-bit SRAM. Of course, you need more than your regular 8 bits, because this is a 14-bit resolution output converter on each channel. So they've got two of these devices. Once again, 500. They're both 512K devices, identical. So I'm not sure why the spec for one of the channels is less than 512K. And of course our main DAC, which is one of the hearts of any function generator, of course. They, of course, haven't skimped. It's an Analog Devices TX DAC AD9781, and as per the datasheet specs for this thing, this is a dual channel 14-bit DAC. Does 500 meg samples per second, exactly as it claims on the front panel, and as they claim in the datasheet for the resolution. Not a problem. And you can see it's an LVDS interface. You can see the controlled impedance pairs going through and their length matching. That's why, of course, I've done talked about this quite often. That's why they've got those squiggly lines on there, just length matching all of those, just to make sure that the signals arrive at the exact time for the DAC. And we've got some more fast comparator action around here. Same device we saw on the back panel. And then we've got a few Intercell 28210 low noise JFET op amps surrounding a good old 74HC 4051. Classic. Gotta have some 74/4000 series logic in here somewhere. And of course, driving all this magic is an ADF4360, and that is a VCO, many gigahertz operating range, so that's what's generating the clock. And of course, matched to that, you've got to have a low noise, low dropout regulator just dedicated to powering that sucker. So they've got a Micrel, what is it, if I can see it, 5209. And that's going to give us a main clock output frequency of somewhere between 2.4 and 2.7 gigahertz. But of course, it's got multiple, it's got divided down, selectable divided down outputs as well. But clearly, there we go. That's going up there. Little bit of length matching in there to drive our DAC. So a lot of the analog performance of this thing is going to be determined by this VCO here, which generates the high frequency clock for the main DAC, of course, and how you power that. You can't just power that willy-nilly from the supply rail and expect to get good specs. So really, they've done reasonably well there. They haven't skimped at all, of course, but that's what you expect. I mean, this thing is, its specs are very, very good for a for any sort of oscillator, let alone one in this sort of price range. And we haven't showed you the relays yet. There they are, NEC UD2-4, something like that. Anyway, they are NEC branded. Really crappy looking inkjet printing, labeling, identifier on the top of those things. Ugh. Now, if we have a look at the bottom of the board here, here's the 4 relays for one particular channel. And you can see they've got all the matching pads, and they've physically removed the ground fill directly underneath those pads. Normally, you might do something like that to just decrease the capacitance of the individual pin to the ground plane. You might be able to save, half a puff or something, that reduce your capacitance to ground by half a puff or something. But because this is a 4-layer board, there's going to be an internal ground plane anyway, unless they've actually left off the ground fill inside the inner ground plane as well. But you can see they've also done similar stuff around here as well. So maybe they do actually know what they're doing in that respect. And over on the more closer to the output side here, they've also done it here as well. So I think they probably know what they're doing there, just trying to reduce that capacitance by half a bee's dick. And the output circuitry here, we've got some exposed copper on the bottom here, lots of vias. That tells us that the chips on top have a thermal pad, and clearly they're trying to heatsink those. So let's find out what those chips are. Aha, no real surprises. Texas Instruments THS 3095, high speed, low noise, high voltage, high current, current mode op amps. So these things are maximum bandwidth 210 megahertz, sort of pretty much perfect for the application required here. Now, I'm not entirely sure why they've sort of surrounded all this with sort of like a big dip footprint. It's almost as if like another, like a design to have possibly another module in there, or something like that perhaps. Whether or not they were going to abandon this circuitry and put it on a secondary module, whether or not there's a second module that plugs in there, not entirely sure. Now, because this is only the 80 megahertz model, does that mean that the 160 megahertz model has something additional in here? I don't know. If anyone with a 160 megahertz model of this thing can open it up and confirm, that'd be really nice. So yes, they're the pads of every alternate resistor there that they've removed that ground fill on, plus the traces go into them. So clearly they're just reducing the capacitance to ground on those individual high-speed nodes. Very tricky. And clearly they meant for a shielding can to go in here, because take a look at the classic mounting points there for that shielding can, which would go over that whole thing, and also there'd be an internal shield in there just separating the relay modules from the output drivers as well. And the main output coax connector here, they've got that running internally underneath, so you can't actually see the traces on there. It's running between the internal ground planes. And you can see the isolation split in the ground planes here, of course, separating all of our output ground reference to our mains ground reference stuff that we had. And of course that's our data optical isolation barrier in there, all the data coming over. But you can see that it also goes up to here to one of the output connectors as well. So one of the output connectors is mains ground reference, while all the others aren't. And if you have a look at the back panel here, ta-da, there we go. We've actually got two of them that are mains earthed reference, because there we go, they don't have the white insulating thing, and three other isolated ones. So you can actually tell where they come from on that connector, because these ones are the isolated ones here on this connector, plus one, so there'd be two connections on that one, plus one on the other one, and obviously the other two are connected to this side of the ground instead of the output side. And as for the soldering quality on both boards, well, pretty much first class, no complaints there whatsoever. And even the high thermal capacity coaxial connectors, not a problem. As you've seen, these two boards are designed and manufactured pretty much first class, and certainly more than adequate for the price range, that's for sure. We're only talking a $600 unit here for the low end one I've got, and just over $1,000 for the 160 high meg unit. But whoever designed this thing certainly knew what they were doing from a function generator point of view. They've used certainly top class components. I don't think they're overclocking anything at all. Everything seems to be within spec. Don't know what's going on with the rubbed off number chip here. Bastards. But anyway, it seems like they really know what they're doing in this thing. Probably, I would be fairly certain that it would certainly meet its specs for its, fairly demanding specs it's got for its performance. So, not a problem whatsoever. Thumbs up on the electronic side of things. But the chassis? Oh, come on. You got to be kidding me. Rust straight out of the box. That could be their new slogan. Unbelievable. It's just flimsy crap, folded metal and spot welded and rust as far as the eye can see. Unbelievable. Thumbs down. What an absolute shame, because the electronics is, pretty darn impressive. Not a problem whatsoever. Just let down by stupid chassis. Gotta be kidding me. Facepalm. And once again, just like we saw with one unit on the top of the board, we've got some current shunt shenanigans going on here and here as well. So we've got a total of 3 of those. Oh, by the way, these output connector boards, nothing much doing on there at all, but they do have a couple of surface mount transformers on there. Quite neat. And just for completeness, here is the front panel. There were a couple of screws on here. Nice looking output connectors. They look really huge and massively solid integrated in there. Really like those. They should last quite some time. We've got some EMI tabs up here to connect through to the main chassis there. There's our, once again, they've got tape. Nice attention to detail there. Tape holding down the flat flex cable connectors there and there, so that's very nice. Nothing much doing. Of course, this is going off to the front panel full color TFT display. There's our USB connector over there on its own little separate board, but apart from that, Once again, you can see the RF EMI shielding along the base of this thing. They've got that along actually all four sides in there. Excellent. They've done pretty well in the EMI side of things here, that's for sure. Once again, you can see the horrible rust on the front panel there, where they've clearly, like, you know, scraped away, deburred this thing. It probably doesn't show up on camera as well as I can see it with my eye, but you can just see the scrape marks there. Ah, absolutely horrid. Maybe if there we go. Look, you can see them clearly, and it's just rusted all the way along the front there, under that front panel bezel. Unbelievable. And by the way, I don't particularly care for the self-tappers they're using to secure this front panel on, but I guess, you know, it's not something that you'd take off all the time, so Well, here we go. It's almost back together except for the top case, and hopefully I've plugged everything in, and yeah, well, let's switch this sucker on for the first time and see if it works. Hello, Siglent! Woohoo! There we go. We're up and running. Not a problem. And bingo, we're in. That's pretty fast boot. I like it. Works a treat. There you have it. That's a teardown of the Siglent SDG5000, or in particular the 5082. 80 megahertz, 500 meg samples per second, function arbitrary waveform generator. And well, I was extremely disappointed at the quality of the chassis in this. Absolute thumbs down for the mechanical chassis quality and construction. Just awful. It's what I expect to see in one of those $50 cheap-ass, no-name, you know, power supplies you get on eBay or something. You know, 30 amps at 30 volts at 5 amps for $50. You know, you expect to get a rusted old metal chassis with the bloody thing, but not in a, you know, Siglent, who are, you know, a quality brand these days, or at least they're trying to be, and the performance of some of their gear is, you know, really quite good. And this thing, you know, has really good specs for the price. Great bang per buck, but geez, the quality of that chassis just very disappointing. Very flimsy metal, and then you know, it's just rusted everywhere as far as the eye can see. Unbelievable. But of course, the electronics in this, absolute thumbs up, first class, not an issue, couldn't fault it in any way, shape or form really. So overall, what's it going to get? Well, it's certainly not going to get a thumbs up because it was let down by the stupid, rusted, crap metalwork in this thing, but you know, it's offset by the decent, high quality, well-designed electronics in this thing. So, well, it's up to you how you want to call the overall, you know, rating this thing, whether or not a rusted, little flimsy metal chassis matters to you, and whether or not that's actually typical of these units or not, or whether or not I've got some dud or something. But yeah, it's definitely not going to get a thumbs up from me overall, apart from, even with the high quality electronics in there, I just left a bad taste in my mouth, the rust. Give me a break. There we go. Yeah, it even tastes like rust. Yeah, unbelievable. Give me a break. So yeah, oh man, it's almost a thumbs down overall. You know, barely a thumb sideways. Unbelievable. But if it didn't have the rust, even with the flimsiness of the metalwork and stuff like that, and the you know, the cheap spot welding, I still would have been very impressed by this thing, I think. So yeah, just let down by something as silly as just a mechanical thing like that. Unbelievable. If you want to discuss it, you know where to do it. The EEVBlog forum is the best place for all test equipment, and Siglent are actually on the EEVBlog forum as well, so it'll be very interesting to see what they say about the crap rusted metal chassis in this thing, whether or not it's typical of this unit or typical of the construction of these things, or whether or not I've just, you know, somehow got one that's just left on the dock somewhere and it was just rusted away to the hilt. I don't know, but anyway, EEVBlog forum is the best place on the internet to discuss test gear. Definitely jump on over there. And I don't mention it much, but if you want to follow what's going on with me and the blog and various other rants on a daily basis, Twitter is the best place to do that. I tweet a lot. EEVBlog is my Twitter name, and so follow that. And yeah, Facebook, yeah, whatever. I've got some Facebooky account thing. I don't know. The videos get auto-uploaded there, but don't send me any messages on Facebook. I don't read them. But Twitter, I definitely do. Anyway, I hope you enjoyed that little test equipment teardown. I know a lot of people get a bit sick of seeing test equipment teardowns, but I personally like test gear and I like tearing them down. So that's what you're going to get a lot of here on the EEVBlog. Catch you next time.